Hi everybody, this is an electric field hockey app. We have a black puck that's positive and we have a goal over here. The objective is to put charges down in such a way that as we get the charges close to the puck will react to that charge, and we want to aim the charge into the goal, like so. So we can hit the reset button. Now, what I want to do with this, we will get into some of the other ones where we'll have objectives like this and this, but for the moment I want to basically utilize this as an opportunity to see how the electric field changes with multiple charges and how the puck will react in the presence of other objects. So if I get rid of the positive and instead I put a negative, which is also pulling here, and I hit the start button, we see that what happens is our puck is now oscillating. It's always pulled back to the center and it can't make it to the goal. All right, so what I'll do is I'll put a setup similar to what we had in class. This is known as a dipole because there's a positive and a negative pole. And as we talked about, we know that this charge here is going to be attracted to the negative. It's going to be repelled by the positive, and we're going to see its motion in the presence of these two. As we can see, it's relatively trapped, and effectively it's looping around the negative charge, and the positive charge is keeping it from coming to the other side, and there isn't enough to get it to go, but it clearly will not sit still. So now we take another version similar to what we had set up in class, only now we have the positive that's much larger and the negative's a little bit smaller. So this is the condition wherein we can have a situation where the net amount of positive and negative are approximately equal. So we can change this setting so that the arrow from the negative is approximately the same as the positive, and hit the start button and it just goes right out. We hit reset, and we're looking for the point where the electric field near the puck is approximately equal to 0. We hit the start, and again we've got the puck getting too close. We'll hit reset. It's a bit of a delicate thing. I wasn't able to correctly get it exactly at 0, but I'm going to put the trace on and see what we get. And there it just disappears again. So I'm going to move a little bit closer. Start it again. Gets caught in the puck. But it's possible if you get it set just right, it'll move very slowly at its initial, and it will not have enough net energy to escape, and it ends up getting caught. So now I'll just move this a little bit further away. So it's a bit of an effort to catch it just at the right point, but getting the exact point where it's 0 on a straight line, it's not going to be quite right. So what I want you to do for this assignment is I want you to ignore the puck, and I want you to basically draw the electric field lines that you see here in this pattern. A single negative charge and three positive charges here, and basically make a set of electric field lines. Instead of all these little arrows, use the pattern that I showed in class where you draw single lines that are proportional. So you have a proportional group of 3 here, and you have a single one here, and draw a set of lines that will approximate what's happening with the electric field that you see here. And it doesn't have to be exact in terms of its configuration. All right, so let's take another setup. Let's look at what happens if we have 2 negatives. So now our positive puck is going to be attracted to both of these. We have a new dipole, and you can see the electric field. I want you to also draw this configuration, 2 negative charges, and show with those negative charges approximately how the electric fields act around those 2 charges. And we can see what the motion of the puck would be if we release it from this point. I was hoping to get it to oscillate between the two, but I couldn't get it quite right. And so what I ended up with was this unusual patterning where it's basically switching from one to the other. And this is a little different than what I had before. Let me just try and line this up perfectly vertically. Yep. Put you back. But you can see this particle is basically trapped around these other charges, making orbits around them, which is something that will often happen with molecules that are ionized in air, the type of patterning that we typically don't see. All right, and so now I have my last and third configuration for you to draw. Draw the electric field line configuration for a group of 3 charges, a group of 4 charges, and a group of 2 charges, and use the electric field line drawing to accomplish that. And I will show you here what the puck will do when it's released. So it will go immediately there, and as you can see, it's effectively trapped. But if it gets just enough energy, it will escape. So because of the fact that there is a net of 7 on this side and only 2 over here, it's not enough to keep it entirely held where it is. But if I were to add another negative charge, now it's a little bit stronger. Now we see that single difference. All of these field lines have changed. So this is what it was before. We had this area here where it was nearly 0. But if I add that extra charge there, now all of these are pulling back in. And now that charge is effectively going to be trapped at that location, although it did actually get enough energy to come out. All right, so that's the end of this particular demonstration. I'll have a second one that talks more about the original objective of this, which is the field hockey.